Okay, thank you everyone. Good morning. Yeah, my name is Henrique. I think you already understood that. And over the next 15, 20 minutes, I hope it's going to be a really practical set of principles and tactics that we use to build an AI product that I think you can take home and maybe apply to whatever you do. But first, I wanted to take a quick step back. So we're going to go back like 30 years. And in 1995, Netscape IPO'd. I don't know who remembers what Netscape is, but it was like the first internet browser. And you can look this up on YouTube. It's still there. There's an interview that CNET goes to the Netscape offices and they're touring around. It's exactly what you expect a 90s office to be, like cubicles, like paper everywhere, everybody drinking a Coke, large desktop computers. And at some point they interview Mark Andreessen, right? And Andreessen was maybe 24, 25 at the time, a new millionaire, had been on the cover of Time magazine. And the last question that the interviewer asks him is, so what is Netscape's secret? And he could have talked about the technology and how it was the easiest way to go online. But I think what he replied is maybe one of the most important lessons for us building technology products. Because basically what he said is, Netscape's secret is that we're in the middle of an exploding market. And this explains most of what's happening. And from kind of every few years, you have a new exploding market. Maybe it's mobile, or it's the internet, or it's sharing economy. And it's one of the few opportunities that we have to build a generational company and something that can grow very fast and people can actually use. And over the last few years, we've been building at Rose a spreadsheet. And I think we have a lot of notes of how we're doing that can be helpful for you. And so AI is obviously also an exploding market. So when you look at technology adoption, it's getting faster every year. So whatever new technology cycle, people are adopting it faster. And so when you look here, this is basically a chart that shows adoption in US households of different technologies. And you can see that as time goes by, technology is adopted faster. So for example, for fridge, it took 40 years for 80% of households to have a fridge. But then with social media, it took 15 years to get 80% adoption. And we're probably there already with like ChatGPT and equivalent. So each of these new exploding markets gives us an opportunity to build something bigger, faster. And when we look at the breakthrough products for each generation, we also see a similar trend. So we see that the time from 0 to 1 million users for Netflix took 3.5 years. For Twitter, it took 2 years. For Spotify, 5 months. And for ChatGPT, 1 day. Right? So I don't think it's unreasonable that the next breakthrough app will have 1 million users in 1 hour. Right? Distribution gets larger. People get more used to the distribution channels that exist. They're more excited to try things on. More people are online, etc., etc. Right? And that's also our story. Right? Our story at Rose.com is first growing very slowly and then rapidly. We like to say that it took us 5 years to get to 100,000 people. And then we rode the AI wave. And then in the next 5 days after we launched, we got 100,000 more people. 6 months later, we had 1 million people. So kind of this, we haven't done anything very different outside of being, I think, kind of in the right place, more or less in the right time. So it took many attempts in the last 5 years. And then there was kind of an inflection point. And the truth is that it would have been much better to have gone viral now in 2025. But what happened was that in 2023, we released our first version of what we call the AI Analyst on top of ChatGPT, I think GPT-3 at the time. And we did like a media briefing. We sent it to a few content creators. On Twitter, there were a lot of people getting very big talking about new AI tools at the time. And the product went absolutely viral. And so basically, one of the influencers came up with this tagline of, maybe you've seen variations of it, but AI just killed Excel. And one of them came up with this, and then everybody else started copying. So we spent 6K on this campaign, got 30 million social media impressions. You see some of these non-sponsored videos going absolutely viral. We got featured on like Argentinian TV. They made a story about us. 1 million signups in the next 6 months. But it was only kind of the right product. It was the rightish product. Like the technology wasn't really there. It didn't work most of the time, but it was just kind of beyond our control. And that's kind of what happened. And so over the last 2 years, we've basically been iterating on what does it mean to build an AI product? What practices do we have? What metrics do we track? What routines do we have? And this is basically what I'm going to share today. Right? And so the way we think about it is that to build an AI product that improves every day, you go through these 5 things. First, as a product person is, how do I pick something that the AI can actually solve? So what heuristic do I have on my mind to pick if this is the right problem to use AI for? Then how do I pick a right solution? Meaning like, how do I not get killed by OpenAI when they do their next release? How do I think about that? How do I think about pricing? So what are the components of pricing? Why are some products free to use or free to try or pay to try? And then how do I establish a culture of using prompts as code rather than just a text document that anybody can mess with. And finally, then what do you do on the day-to-day to actually get better? Right? So we'll go through each one of these. So picking something that the AI can actually solve. I find this a really helpful heuristics when you think about the output from the AI, and if you think about what problem do I apply AI for, I think you can place into a matrix of, does the output need verification from the user, or is it something where the success is clear? And if I need to iterate over the output, is the iteration costly in time or in money or in risk? Or is iterating inexpensive? Okay? And you basically have this 2x2 matrix that you can classify products and solutions for. So for example, if you go to the red one, kind of the worst one, what do you don't want to build? I don't think it's a great solution to build a product that helps people design tree houses for kids, let's say, right? Why? Because if I'm an end user and I will use your product to design a tree house, I need to verify if it's actually going to be safe for my kids or not. So I have a lot of anxiety around it. And if it fails, the iteration is very costly, right? In time, in money, in injury. So that's probably a place where AI is not very good at. The other quadrant, which is where we're seeing these breakout companies, is in the intersection of iterating is cheap and the success is clear. So writing code is a perfect example, because success being clear or not is you click a button, it runs, does it work or doesn't it work? And the iteration is very inexpensive. You ask it again, it generates more code. You ask it again, it generates more code. So it's kind of the perfect application for a probabilistic and not a deterministic product. And then you have these kind of fuzzy areas where we're seeing more companies coming through, but it's a bit less, it's harder to have a breakout success, which is, for example, things like, where the user might not be an expert on the output, and therefore it's unclear if the success is there or not. So if you ask ChatGPT or an AI product to write an essay on 17th century economy in the Netherlands, it's going to write something very profound, but unless you're a trained economist or a historian, you probably have no clue if this is true or not, right? So it's hard to trust that the AI is there because you need an expert verification for it. Or on the other hand, and we were seeing the Parloa example from before, I think this is where we're still adapting. So things like buy me a plane ticket for Hawaii is a tricky one, because even though I can verify if the output is true or not, the iteration can be very costly, right? Like, did you go through the website correctly? Is it really on time? Were there cheaper opportunities? So it creates a bit of an anxiety there. And I think this is why we see that the breakthrough apps, like the 100 million ARR plus products, are kind of in this green quadrant, the cursors, the lovables, the enterprise search tools, because the success is clear and you can iterate many times. And then you see a lot of use cases here. Some of them are taking off, things like deep research or Manos. Deep research has this interesting phenomenon, right? You ask it to do a deep analysis on something, but you actually then need to verify if it's true or not. If you just blindly trust on it, it might not be kind of the best use of it. Right? And that's also how we think about it, and why our 2 AI products are in what we hope and think is a green quadrant. One of them is an AI Analyst. So basically, it's the world's smartest copilot. You can use it to co-build or just build your spreadsheets for you. And then as we were building this, we started seeing that about 20% of people were trying to import PDFs and images into the spreadsheet. So, you could import CSVs and Excel files, but they were actually trying to import a lot more. And that's why we built what we call Rose Vision, which is basically the smartest OCR model in the world. So you can drag PDF files, invoices, receipts, tell it what you want to extract, it extracts to a spreadsheet, and then you keep working on it. So again, something where the success is clear, so you can verify if the invoice is extracted correctly or not. You can verify if the chart or the column is correct, and the iterating over is really inexpensive. So the second thing is, how do you not be killed about OpenAI? So how do you think about how the world will evolve and how your product fits in? We like to think that the right products to build are in the intersection of 2 things. One, they get more valuable as the models get faster and cheaper. And using your product or your solution is 10 times more useful than using ChatGPT, right? So a practical example, let's think of Lovable, right? The vibe coding tool. Lovable gets much better and more valuable as the models get better, right? If the model is smarter, then your Lovable website will run better. If the model is faster as well, if it's cheaper to use, your Lovable subscription will have more value. And at the same time, it's much more useful than just using ChatGPT, because they do the design, you can deploy it, you can publish it. It's a lot more than just the code that ChatGPT spits out. Right? So if you're thinking about the solutions that you might want to use AI for, I think this is a helpful heuristic. So build for a world where if the models are free, cheap, local, does my solution still make sense? Because this is where the world is going, right? And you don't want to be trapped into a solution that only works because the LLM is not great yet, but once it is great, you're kind of out of a business. So models improve faster that you can pivot. LLMs are going after the app layer, obviously, because if you think about the inference costs are really, really high, but then the productivity marginal costs are much lower, right? If you share, maybe it takes a lot of compute time to generate the document. It takes no compute time to share that document and to collaborate. So you will see the LLMs more and more going into the app layer. And so the winners are probably products that get more defensible as new models come in and are much better than just a chat interface. Okay, so don't be killed by OpenAI. Then the third one is thinking about pricing, right? If you have your use case, if you think you're kind of defensible, then how do you think about pricing? And again, I think maybe because we're in spreadsheets, but a table or a matrix is a good way of looking at it. So all of these LLMs, it's basically charged based on token consumption, right? And what this means for the user is basically two things. When they use your AI product, does it consume many tokens or few tokens? And is it a frequent use case or an infrequent use case? Right? And again, the same thing. If using the feature is infrequent and generates few tokens, then you can probably make it free to use because there's almost no cost for you. On the other quadrant, if it's frequent usage and many tokens, then you cannot even afford to give it a free to try. Right? And then you have these free to tries where maybe it's a lot of tokens and infrequent usage, maybe the business case is not really strong, or if it's frequent usage and few tokens. And I think what we're seeing more and more is, again, as the models get cheaper, these things also get cheaper with time. Right? And then here on this quadrant, you have things like agents or large fine-tuning models because it just takes a lot of injection to make it work. So if you look at actual examples, if you think about something like Finn from Intercom or these large image or video generation models, they have to charge just for you to try because they have to ingest a lot of data in your first attempt, right? Like they have to read your documentation, et cetera, et cetera. And on the other hand, if you have a product like Rose or 11 Labs or Cursor or Lovable, there it might generate many tokens, but for example, with Lovable, you're not going to do 10,000 prompts in a day, right? You're going to have a few prompts in a day. It might have a lot of tokens, but you can try it for free. And with Rose, you might do 100 tries a day, but then we also generate fewer tokens, so we can give you kind of for free the same thing with 11 Labs. So it's also this intersection of these two things. Right? And then at the end of the day, pricing is about token usage, and token usage is this combination of this equation of four things. Token usage is your context, plus your instructions, plus the result, plus your reflection. Okay? So what does this mean? Context is basically what does the app know about you when you send it to the model. An example, if you go to Rose, you pull a data set, this is like Airbnb listings from Berlin, and you ask, do a pricing analysis on this data set. What is the context that we sent? We basically send a couple of rows of data from each table in your spreadsheet so that the model knows the structure of it. We send some metadata about the cells, like, column A is an integer, column B is a string, column C is a date, etc. So a little bit of more added context. And we give it a JSON schema of all of the operations. So this is the context that the AI has. So it knows the JSON schema of how to add a column, the JSON schema of how to format a cell. And this is the context, right? This context is, if you do the same question in a different data set, the context is going to be slightly different, but most of it is kind of the same logic. And this is one big chunk of pricing. The second one is the traditional prompt or the instructions. And basically this is based on the context that the AI has, how do we instruct it on what to do? And I think a good prompt tends to follow these, and this is a real example from a prompt, has an objective, so what should the AI do? What does an optimal solution look like? What are specific rules, specific task rules? And then some examples of common errors, for examples, or examples of things that you wanted to do. In our case, our base prompt is 26,000 characters, right? Excluding the context. And we tell you things like, what's the optimal solution? How do you help? How do you become a good analyst? Like, how do you use search tools like Python, for example? How do you add columns? How do we want you to style your charts, etc., etc. So these are the instructions. And then there's the result. And in our case, what we have is what we call a hybrid intelligent model, because if you ask something from the AI doesn't tell you like the result to put on the spreadsheet. It basically gives us a schema on what operation to run. Like, should I use a sum formula or a VLOOKUP, or do I create a chart? And it gives us something like this. So in this case, the AI can also reorganize the layout of the spreadsheet. And here is an example of the JSON that it sends us, like this node ID, basically this element ID in this position and this position and this position, etc. Right? And then we take that and then we interpret it and we actually execute on the spreadsheet. And then finally, there's the reflection. Right? So we know that models tend to, or it's possible that they hallucinate, or maybe they write JSON in an incorrect schema, or they break for some reason. And so after the AI writes the workflow and we try to execute, typically these products have some sort of a reflection step, which is basically telling the AI, this is what you generated, go back and see if you need to fix anything or correct anything. And again, it's a sort of a prompt with the same logic. We have some specific triggers. So if the AI did more than one step, we trigger the reflection at the end. We call it like specify dedicated workers, or if at least one step failed. And it's something like this. Again, here the context is different, right? So you say that you're an agent to validate spreadsheet operations. You'll get the JSON schema. You have the current state of the spreadsheet. And your role is to see goal alignment with the prompt, completeness, correctness, and then we give a few examples. Right? So this is just one way of trying to get the output better for the end customer. So this is the third thing. Right? Now the fourth thing is, how do you treat your prompts as code? I think this is more and more important as more people on your team want to play around with the prompt. I think for us as product managers, this is a really exciting time because it's the first time that we can improve the product just with words, like literally add more features, but it also means we can fuck up things just with words. And so this means that more than just a text document that the devs have, you really need to treat your prompts as code. So how do we do that at Rose? The repository with the prompts is actually on GitHub, just like any other repository. And to make changes on the prompts, you need to push on GitHub as well. So this is an example of a designer, right? A product designer doing a new pull request to enhance the readability of the AI. So when the AI writes text, how does it use bullet points? How does it use numbered lists, etc.? And she's just opening a pull request, right? She opens a pull request. Someone has to review it. It's part of the pipeline. You can go back in time. It's much more scalable than what we were doing initially, which was either me or Alberto, just like changing the document, uploading the document directly on OpenAI and just doing it ourselves, right? So this is the first thing, prompt edits requiring a pull on the AI repository. Then this is huge for us, where each new pull request automatically creates a dev environment, okay? And this means that we can quickly change, test iterations of the prompt. So in this case, Carlotta, or in this case, Alberto, he wants to add a new example of how to do a simulator. Once the branch runs the text, you can do a deployment, and this is a full deployment of the app, but with the change here on the prompt. Right? So we can test on it, run our tests, run our evals, and decide if we go forward or not. And then obviously we have our set of tests, and we have two types of tests. We have manual evaluation tests, which is basically, in our case, a series of data sets, a series of questions, and then does it work or doesn't it work? And now more and more, we're also running automatic pipeline evaluations on the pull request. So in the pull request, you can also comment, run end-to-end evals, and you will do this thing, right? You will open like a Chrome browser, and it will load this data set, and you will look at what is the output from the analyst, and is it within one of the 2, 3, 4 things that we expect, right? Because we know it's not deterministic. Right? So treat your prompts as code. And then the final thing is, after you've done all of this, how do you get better at it every day? And these are the 4 things that we do at a daily or weekly basis to try to build a better AI product. It's kind of Kaizen. I don't know if you know what Kaizen is, but it's kind of a Japanese word for this is change and this is better. So changing for the better. And it's idea that you can actually get better every day at, and it could be organizing your factory layout. It could be your diet. It could be just building a better AI product. And these are the 4 things that we do. Every day we review the success metrics, and I'll show you which ones they are. We review the failed questions, so things that people asked but that failed for some reason. And then every week we do a more thorough review of what are people actually asking from it and what are new models that we should test. Okay? So in maybe 8 or 10 years of working in product, this is the first time that I can tell you that there's a metric that it's actually helpful to look at every day. Right? And we look at every day at 2 things: the answer rate, meaning when the AI gives us something, this JSON, can we parse and execute on the spreadsheet? If so, we count it as a answer. Might not be correct, but that we answered. If not, it's a 0, right? And then the other one is how many prompts per day do we have? Right? And the reason why this is really important is because these AI models are not deterministic. It might be that you change something today, it kind of passed your evals, but then at scale, it actually messes up something. And the reason why we have to check every day is things like this. Like we were on a conference on Saturday, and we noticed that our answer rate had dipped from, let's say 85 to 73 or something. And it had dipped because the day before we had made a change on how to process part of the instructions. We had ran a few tests. It had passed, but then, once hundreds of people are using it at night in the US or whatever, clearly this wasn't working. And so we were basically had to roll back on Saturday. And again, this is not typically something that would happen with another feature, but with AI, this is much more volatile. And so we have to look at this thing every day. And it also impacts the number of prompts per day. So we were just chatting with Alberto on the way here. One of the weeks in which the number of prompts went up a lot was when we made the system much faster. And so again, you want to monitor these things because they can literally change every day. So, reviewing the success metrics every day. The other one is around cost, okay? Because again, as you play around with the instructions, you can increase a lot the token usage, which will have an impact on cost. So this is also something that we see every day. For example, here we were testing sending additional context to the AI model. For example, instead of sending 2 rows per table, sending 10, and this had a big jump on the prompt cost. So it's kind of part of the engineering team is also almost a pricing optimization team because they're looking at the trade-off between accuracy and how much tokens we're spending. Then every day we also review the failed questions. And this basically means this is a real example where we pull from our logs what the user asked. For example, what formula did the AI generate? And then we try to understand why is it wrong? Like, why did it generate this mistake? And maybe we do this every day or every 2 or 3 days. And we end up with something like this, right? From this week or these 2-3 days, how many errors did we have? Why did we have them? What are the quick wins that we can directly do? What are bigger things that we need to add to the product, for example? We also review new models because if you follow anything about the AI space, every week there's something new. And the important thing is just to have an infrastructure that you can easily change the models and call it to test. So what we've done, we've basically have a few frameworks that we use to abstract calling directly a model so that you can call different models where the API is slightly different. And some of the core functionality that we have, for example, chat history is agnostic to how OpenAI does it, right? So it's just like a generic way of sending chat messages that then we can use for any model. And you can see here in the same week, we were testing GPT-5, the open source version, a new version of Gemini, new context, multi-agent architecture. We're basically pulling these new pull requests every week to see, is there a new model that we should leverage, right? And people ask us, what do we follow? This is the newsletter that I always get, rundown.ai. I think it's a good one. This is a good website for benchmarks. And on Hugging Face, you always have the new open source models that you can play with. Right? We're almost in the end. This is my favorite thing maybe that I do every week, which is actually reviewing the prompts of what the users are asking the AI, right? So not what it wrote, not what the tables have. We don't have access to that. All of that is encrypted, but just what is the prompt. So you can see, it's connected to BigQuery. You get maybe the user ID, the message, you need to translate it, and then you try to get intuition about what are people using the product for. That's the whole goal. And then you find some interesting things. You see that people sometimes are trolling with you, right? So this is a user just asking, who is LeBron James? Like just clearly trolling with us. You see people that want to use the AI in completely odd ways. So this user was just asking, are you capable of seeing who doesn't follow me on Instagram? Right? Like the Germans want everything in German. So this is an example of just asking, do you reply in German? Can I just talk in German? And just, you can also see fuck-ups, right? Here, clearly the user is asking, where is it done? Meaning that the AI said done, but it actually didn't do anything, right? So again, it's a good way of gathering intuition about what the product does. Yeah. And I think this is how we think about building an AI product, picking a problem that it can solve, finding a good solution fit, thinking about pricing correctly, treating your prompts as code, and then having a few routines every day that you can get better at. And so again, how do we know this? Because we've built the world's smartest spreadsheet, is in rows.com. We don't even have a homepage. I think this is like a product for a story for a different day. And we're actually announcing this today for the first time. We actually did the first AI spreadsheet benchmark where we put rows against Excel with Copilot, Gemini with Sheets, some of the newcomers with a real-world data set, running hundreds of questions and seeing what is faster, what's more accurate, etc. It's already published on Hugging Face. You can see huggingface.com. Rows HQ, and basically it's a new way of saying that we're here to stay. Please give it a try. And this is basically it. So we have a small booth if you're interested in what we're doing. And thank you very much.
Thank you, Enrique. And you said you were in the right place at the right time, but also you are doing a lot of right things. I mean, it's not only being on the right place at the right time. So we have time for questions now. Does anyone have a question for Enrique? This is your chance. Please just raise your hand if you there. We have one or two.
Thank you for the talk. That was super interesting. Regarding the metrics you shared, you also had that, or the things for you do for continuous improvement. You said you review failed questions. How did you define failed questions again?
So when the AI gives us the answer, so this JSON output, we have to parse it and try to execute it on the spreadsheet. If that fails for some reason, we call it as a fail answer. It might be that we don't support the formula, the Python script is broken, the JSON is broken, and that's what we call as failed. We don't know if it was useful, let's say. We only know if the user came back, if they kept asking questions, but just, did we even compute it or not? That's what we're looking at.
Okay, thank you for explaining. And do you also look into this user behavior, like user keeps coming back and iterating on their questions and get a sense of they didn't get the answer yet they're looking for?
Yeah, there we don't look at that every day, but we have user cohorts, right, of people who use the AI. Do they come back the following week, and this is a way to give us intuition on that. And also when we look at the actual questions, you can see how did the conversation end, and this is a good way of understanding if people are happy. Sometimes they tell you, thank you, this was helpful, or you didn't do it, or what is this, and then they leave. Clearly we didn't solve it, even if it was a success from the computation standpoint.
Thank you so much.
Thank you.
You mentioned about your strategy and also like day-to-day or weekly, how you look at the metrics and improve things. When you look back your last 6 months progress of success, what percentage of that success comes from your like weekly and daily Kaizens?
Good question. I think maybe 80% of the improvements we've had over the last like 5 or 6 weeks was a big architecture change. And the big architecture change was, I think, understanding, I think maybe like 20% are low-hanging fruit of stuff that we improve every day. And then the rest are bigger changes that this informs us, but it's not like we see an error on Monday and we can fix it on Tuesday and it's much better. It just takes longer. So I would say maybe 80-20. But these things are really important to get intuition about like what's working and not working.
Hi, good question about a point that you made about pricing, where the puck is going, my number 3 right there. How far can you predict, or how far do you bet on pricing going down or being more efficient?
I think it depends how much money you have in the bank. Because I think we're very close. Like we already use an open source model in the AI Analyst for a small task. And the open source model is basically free. Like we run it on Grok, this fast inference thing. And so we think that within the next 12, 18 months, I think we'll be running most things on open source, and then the cost is not really a problem. For now, we have to look at it every day because at thousands of users using it at 8, 9, 10 cents a prompt, it gets expensive. Right? So when we build a new solution, we're not tied to the cost, but we look at the cost every day as a measure of, for example, do we need to give less to people on the free plan because we need them to upgrade faster because they need to make up the ROI. That's more of the reason. But honestly, like we're getting the prompt cost down. I think it's at 8, 9, 10 cents. I think it can be a lot less if we optimize, but we haven't optimized for price yet because we just focused on getting the product really well. Sorry? I think up until maybe the last year, it seemed to be somewhat of a Moore's law. But now after GPT-4, 4.55, it's cheaper, yeah, but it's not 10 times cheaper. Right? Maybe it's 2 times cheaper. And I think maybe we'll get another 2, 3, 4 times cheaper. But what I'm hoping is that most of the B2B tasks that we want to use, the model doesn't need to have PhD level at anything. It just needs to be deterministic on the JSON structure and what you need, etc. And I think we're getting close to it on the open source level as well. And those are much, much cheaper, even if they're hosted by someone else.
We have time for a last question. There was like a hand up there in the corner. And then I'm sure Henrique is going to be around if you want to ask more questions later on.
Hi, first of all, thank you very much. It's been a while since I tried to take a picture of every slide. It was very useful. I want to ask one question, which is regarding, like, I understand the failing rate, but I also want to understand how good you measure if the answer was actually a good answer. Because when you try to make AI evaluate itself, it is either becoming too perfect, too egoist, like, oh, great job, or it's becoming too cynical and say, oh, I did a failure of a job, I could have done this better. And how do you actually proceed to evaluate your answers? Because this is where I'm kind of frustrated with my own work at the moment. Yeah. And I would like to hear your opinions.
If you have a product for end users like we have, the only thing that matters is retention. If it's good, people will come back the next day, the following week, the following month. If it's bad, they'll upgrade and then they'll churn. Okay, so I think this, at the end of the day, it's the only thing that matters. And so for us is every week we look at the churn customers. Why did they churn? How much did they use the AI? What feedback did they give us about the AI? And that is, I think, the biggest proof point of did it work or not. We discussed, should we add a thumbs up or thumbs down, for example? We always said no, because it's going to really be a biased sample. A small percentage of people will click yes or click no, and then maybe you over-index on the people that said yes. I think is you go through you go through it diligently to see what the AI tells us. You talk with customers. If they retain, they're happy. If they churn, you don't have a good product. Sorry?
It's a little bit of high risk.
I don't know if it's high. For example, we try many times, let's send an email to everybody who used the analyst more than 20 times yesterday. You get really low reply rates. And so it's really frustrating to try to get a lot of feedback from people. You need to use the product yourself a lot and then see at the behavior, like, do they use it more or not? And sometimes you have people who don't reply to any email and use it, we had to use it like 70 times in one day prompting. Right? Clearly it worked for something for him or her.